the world's largest hydrogenation reactor. Weighing 2,400 tons, with a diameter of 5 meters, a vertical height of 70 meters, and a height of about 20 floors, it is the world's largest hydrogenation reactor. This is the Zhenhai Boiling Bed Residue Forging Welding Hydrogenation Reactor, developed by China Yizhong Group. It is a super-large mechanical equipment developed and constructed by China Petrochemical Group Luoyang Company, Limited, and first ordered by China Yizhong Hebei Xinhai Chemical Group. This is the world's largest residual oil hydrogenation equipment, as well as the world's largest petrochemical equipment and largest reaction vessel by far. Due to changes in the global fuel usage structure and increasing demand for light fuels, a key focus in the chemical industry is on improving the conversion rate of crude oil to light fuel. The currently effective method is the residual oil hydrogenation process, which utilizes high temperature, high pressure, and catalysts to decompose macromolecular substances into small molecules, thereby producing qualified light fuels. The requirement for pressure vessels in this reaction is extremely high, so the importance of this equipment in China's chemical industry is self-evident. As an effective means of deep processing of heavy oil at present, the boiling bed hydrogenation method has a more flexible operation, which can convert difficult-to-utilize heavy oil and residual oil into gasoline and diesel with higher economic value. Its prospects worldwide are quite broad. It is certainly not an easy task to manufacture this device. The requirements for construction materials are very high. Not only should they meet various testing standards for parameters, but also a comprehensive inspection of the quality control of the steel should be carried out. All tank steel plates should have uniform density and toughness, and there should be no defective parts. Because during the exercise of oil products, chemical reactions occur and the temperature inside the tank repeatedly changes, resulting in poor quality steel and potential safety hazards in production. Only by addressing the raw materials of this special composite steel can it be possible to further advance in technology. China has achieved localization in the overall technological process, and multiple technologies have obtained patent certification for independent intellectual property rights. In this regard, Yizhong Group has put in a lot of effort for several years to successfully launch it. The fluidized bed residue hydrogenation technology has extremely high adaptability to raw materials and is flexible in operation, which can reduce coking load and perform outstandingly in terms of utilization efficiency and environmental protection effects. In the manufacturing process, due to the different structure of fluidized bed reactors compared to traditional fixed bed reactors, their internal components have complex installation processes, high processing accuracy, and great manufacturing difficulty. The majority of process technicians and frontline employees have strict project management, strict process specifications, and strict quality supervision. With exquisite manufacturing technology and a solid work style, they have successively overcome many difficulties such as reactor length and overweight, heat treatment, flaw detection, and welding difficulty, and completed manufacturing tasks with high quality and efficiency. Its successful manufacturing not only enhances China's specialization, innovation, and core competitiveness of Yizhong, but also once again refreshes the development performance of China's super-large tonnage forging welding hydrogenation reactor, writing a new chapter for Yizhong to achieve the localization of major petrochemical technology equipment. The residual oil that has undergone deep processing through hydrogenation reactors can continue to extract more finished oil, and the category and quality have greatly improved. This not only makes important contributions and assistance to China's oil production, but also contributes to environmental protection. For the degree of crude oil extraction in the past, there was only a conversion rate of about 40%, with 3 of them becoming diesel products and 1 becoming gasoline products, and the remaining residual oil may have to be wasted while watching. The oil that has been painstakingly detected, after undergoing very complex technology and manual extraction, has only achieved such a low conversion rate, indicating that the use of energy is still stuck in technology. With the addition of this large hydrogenation reactor, the utilization rate of domestic oil can be increased to over 90%, while in the same type of equipment, the West can generally only reach 60%. As the blood of modern industry, petroleum, a non-renewable resource, can break through the technology of oil extraction and utilization, equivalent to creating a key bottom card for the country's industrial development. The outdated oil processing equipment has caused significant losses in Europe and America, with Canadian oil producers alone experiencing losses of up to $20 billion in 1 year. In order to install this 2,400-ton behemoth, China has also set multiple world records for the lifting of petrochemical equipment. Due to the insufficient lifting capacity of the dock crane, 2 850-ton cranes and a 1,600-ton floating crane vessel were used to transport it ashore, setting a new record for the lifting of goods in the Yangtze River waterway. Installing it in place itself indicates that China is in the technical field of large-scale petrochemical equipment installation. It has also led the world. China has never stopped researching and exploring petroleum processing technology. Through unremitting efforts, we have finally broken through the bottleneck and developed and built a unique hydrogenation reactor in the world, achieving new achievements in petroleum refining. The main reaction process requires the addition of hydrogen cracking, as well as the high-quality finished oil required for hydrogenating. It can also be used in the field of coal chemical industry for coal hydrogenation liquefaction reactions and the production of liquid fuels and other technologies.